Okay, stats class, we're here for our second example. Notice you should have done example one with me in class. If you haven't yet, please open up your homework so that you can do this along with me, and then you're going to do examples or on your own one and two on your own and submit that for homework. So this one talks about average high temperatures in Akron as well as Wellington. And you can see that if the temperature is 33 degrees in Akron, Wellington 67. If it's 82 in Akron, it's 51 in Wellington. And if it's 49 in Akron, it's 60 in Wellington. It seems that they're working indirectly. As one goes up, the other one goes down. And that would make sense because Akron is in Ohio and Wellington is in Australia. So they are on opposite sides of the planet. And so that's going to change in the opposite hemisphere. So that's going to change the ways in which they kind of get the temperatures that they do. So they kind of have different seasons altogether. But we want to be able to have a mathematical reason for describing this relationship. And so we're going to need to produce a scatter plot. And the way we produce the scatter plot is we go ahead and we just type in that data. So Akron and Wellington. Then under Akron, we have 33, 37, 48, 59, 70, 78, 82, 80, and then 73, 61, 49, and 38. And then in Wellington, I'm going to pair that up with 67, 67, 65, 61, 56, 53, 51, 52, 55, 57, 60, and 64. It doesn't look like temperatures change a whole lot in Wellington. A lot more change in Akron. So we're going to go ahead and we are going to select that data. And I'm going to move this right on over here. We are going to insert a chart. And Google Sheets is going to do its best to choose the chart that it should. And it does produce a scatter plot, which is really nice. So if it didn't, we would have to change that. I'm going to show you how to do so. So right now, it's produced a scatter plot for us. Whoa, I don't like it when you do that. Okay, it's produced a scatter plot, which is great. Now I'm going to select it and drag it over here. And I'm going to click on these three buttons to edit chart. If it didn't produce a scatter plot, go ahead and scroll down to select the scatter plot. But it did produce a scatter plot. So because of that, all I need to do is go over to Customize and go into Series. There are three things that you have to add. I noticed that looking at some of your other graphs that some of you chose to add data labels, some of you chose not to. Some of you guys were a little bit more refined with some of your changes that you made for your graphs and displaying it. You have to add these three. This is an absolute must. You must add a trend line. You must change the label to use equation, and you must show R squared. Now that I have those three done, I can click out of my art or my editor, my chart editor, and I can look at this graph. And sure enough, you can see that it is negative 0.318. So we produce the scatter plot of the data, describe the relationship of the data, strong negative correlation. That means as the temperature in Akron increases, the temperature in Wellington decreases. Okay, so that gives a very good description of our data. Determine the correlation coefficient. It says R squared is 0.941. We don't want R squared, we want R. So go to Desmos and we do the square root of 0.941. We have 0.97. So R is equal to 0.97. Not quite. The fact is our R value should be negative. When you take the square root, it only produces the positive. But if you look, your slope was negative, so our R value is negative as well. So we're going to click on that and change that from r equals 0.97 to negative 0.97. Make sure that you show that it's negative. Determine the equation for the best fit line. Wellington, or W, is equal to negative 0.318 times x in this situation is Akron, and then plus 77.7. It says, using your best fit line, what would you expect the temperature to be in Akron if Wellington had a temp of 70? So I'm going to go to my dry erase board up here, and it says, this is my best fit line, and it says, what would the temperature in Akron be if Wellington had a temperature of 70? So I type in 70 here, equals negative 0.318 times A plus 77.7. I subtract the 77.7 over, I get negative 7.77 is equal to negative 0.318 times Akron. I'm going to calculate that on my calculator. So I go to my calculator. I have negative 0.318. Whoop, I'm sorry. Negative 7.77 divided by negative 0.318. And I get 24.43. Akron temperature equals 24.43 degrees. I think that's what we had, 24.43. Yep. And then the last question is, use your best fit line. What would you expect the temperature to be in Wellington if Akron had a temp of 90? So we're going to go ahead and change that. We're going to change it so Akron has a temp of 90, so we're going to put the 90 in here. So Wellington is equal to negative 0.318 times 90 plus 77.7. Go on to my calculator, and we take negative 0.318 times 90 plus 77.7. We get 4908. Wellington temperature equals 49.08 degrees. There you go. It's a really good introduction into linear regression. You produced a graph, you found R values, you found slope, you found an equation for best fit, you answered some questions. And so you're going to, again, make sure you have the in class 1 and in class 2 done on your own, and or done in class with me, and then do the on your own 1 and the on your own 2. Make sure that those get submitted via Schoology. If you have any questions, please don't hesitate to reach out. I sit here a lot of days kind of waiting for people to ask questions. So I'd love to be able to sit and visit with you over a video and talk about any questions or concerns you have, and be able to clarify anything that way. Have a great weekend, great week. Enjoy